Hi, I'm Paul Battaglia, and this is section 5.2, Verifying Trigonometric Identities. In order to keep the continuity from section 5.1 to 5.2, we're going to ask students to go from using fundamental identities to now verifying them. And in essence, what that means is we're asking students to basically prove that a certain equation is true. Now, this might cause some trepidation among students, but the way I try and mollify that a little bit is to try and get them to understand that there's some closure now. See, in section 5.1, they had expressions that they were trying to distill down to something, but they didn't quite know when they were done. Section 5.2, now they'll know, okay, if I can just get this expression to equal this, I've done my job. But the process in doing so, not so easy. So I've brought along Gabe and Brittany, and they're going to help talk to us a little bit about how you can structure a lesson for students that really helps them master this. So Brittany, talk to us a little bit about what you want students to understand going into the process of verification.
I like to tell my students that everyone is going to be unique. So every problem they see, they're going to have a different first step.
Okay.
And some of them you'll have 3 or 4 steps to go through, and some of them you only need 1 step to go through.
Right. And it tries to get them out of that idea of patterns. They like patterns,
Yes.
but and there are some patterns here, but not I think the traditional ones that they're looking for, right?
Yeah.
I think the interesting thing is sometimes students will ask me, we'll talk about the techniques that they could use algebraically, but a lot of times their question to me is, I don't even know where to start. You know. So Gabe, talk to us a little bit about where you would tell students to start.
So really there's plenty of places to start these problems, but before we even start using any algebraic techniques or using any of the trigonometric identities, I like to have students first determine which side looks the most complicated.
Okay.
And from there, I tell them, maybe let's try to simplify this to get it to look like the other side of the equation.
Okay.
So for instance, we don't want students starting with the simpler side and trying to make it harder looking.
Right.
So for instance, we wouldn't want to start with, let's do something simple like sine of x times cosecant of x equals 1. If we want to verify this identity, we probably wouldn't want to start with 1 and then try to introduce trig functions into there or something. So I would say, let's take that back to just looking at sine and cosecant and what identities can we use there to maybe turn that into 1.
Yeah, that's a great idea. And I think if we can do that, then we're trying to tell students and show them that yes, there are all these different techniques we can use, but even though you may not know where to start, at least you know that you're going to make some progress if you go from hard to easy. You know, I think one of the other things we have to do is we have to stress to students patience. You know, they're going to need to be patient here. They're going to need to fail a little bit here. They're going to need to mess up, scrap the problem, start over again. And I know sometimes, Gabe, you have a nice little technique for just trying to ask your students to just give me some stuff. Let me go with stuff, right?
Yeah, so an exercise that I like to do real early on in this section is just to give my students a pretty simple verification or identity to verify.
Right.
And I write it down on the board, and I just have students call out identities which are true that I can use to rewrite one side. So what I'll do is we'll start with one side. I'll say, give me some identities here, and I'll take all of them into consideration, and I'll try to use them as we go. And maybe what'll happen is a 1, 2, or 3 step problem will somehow become a 10 to 15 step problem, and we're not even getting any closer to the answer. So what I do here is I say, okay, let's stop here, let's go all the way back to the beginning, and maybe we can change this first or second step and maybe get a little bit closer to the answer a little bit more quickly.
Yeah, and along those same lines, don't be afraid to maybe prep the lesson a little bit on your own and go find an identity that you have that you can tell has multiple approaches to it, and give that one to your class and try and maybe group them up or pair them up and see the different approaches, and then ask those groups to present them for you so students can see, if I don't think of this, that's okay. I could always do this, and that's true of a lot of identities, really, All right, so there's one more question then students are going to ask. So the where do we start question is important, right? But naturally, with something so analytical, the question of why is going to come up. Why do I need to know this kind of stuff? Brittany, talk to us a little bit about what we would tell them.
All right, so I'd say, well, when you're going on to calculus, we're going to be dealing with complex concepts. And so do you want to also have to have a complex equation or a complex formula to also deal with?
Yeah. My first thought was sort of maybe integration. That's something that we can't integrate some trig functions just the way that they're presented to us. But we can use the ideas from this section to maybe simplify these into
something more
Yeah.
more doable. Yeah,
And
I
the
think that's
functions
important.
which we can integrate.
Yeah, and sometimes it's far off and students don't quite see that right away. But if you're talking about being in a course such as this where you're using analytic trig and it's it's precursor to calculus, right? It's reasonable to assume that there are a lot of students who are going to go down that path. So I think it's important that they spend some time on it for sure. We'll give you one final idea here. One of the things you might want to do with your students is make a list of all those algebraic techniques that they can use within a problem, emphasizing the idea that you would probably use more than one of these techniques at every step of the process. So maybe we put on the board things like, think about rewriting in terms of sine and cosine. Think about using a least common denominator. Think about factoring. All of these ideas we try and give them so that as they approach the problem, we can get them to think, okay, step one, I factored. Now what? Well, this helps them answer that now what question. Okay, well, I factored, so I'm probably not going to do that again. So maybe I can rewrite it, or maybe I can use an identity. Kind of a checklist. And if we can get students to think like that, they are mastering the process, but in the process of doing that, they're becoming more efficient. And I think that's important.
Yep.
And something that I just want to mention before we wrap up this video is the idea that what you don't want students to do is you don't want students to start the problem by swinging stuff over to both sides of the equation.
I agree.
So you really want to emphasize that students need to work with one side of the equation first and take that to the other side of the equation.
Completely agree. I hope you found these tips helpful and you find much success in section 5.2.